Today we're going to do the lab discovering friction, and there is a pre-lab, so let's just discuss a little bit about what's we need to do in pre-lab, and then we can go over what we need to do in this lab for discovering the friction. The pre-lab portion basically is a block that is on the inclined surface with the angle theta, and we are going to basically find out what are the forces acting on that block, and we are going to draw the free body diagram and analyze all the forces, and basically from that we can actually find out what would be the coefficient of static friction, and in terms of the angle theta of this inclined surface. Okay, so that is the part that you're going to have to do and find that relationship between the angle as well as the other forces involved here, and find out what would be the coefficient of static friction. Now, when you have the block on this plane with a certain angle, you can increase the angle, and at some point the block starts moving, sliding down. So when it starts sliding down, you have the coefficient of kinetic friction. But before that, you have the coefficient of static friction while the block is actually stationary on the slope. So then we're going to take a data for different. So this is the first part, okay? The first part of the actual experiment deals with a block that's sitting on the surface of a table, and we are going to apply a force pulling this block, and as a result we're going to find out again what are the forces acting on this block, and you're going to have to draw the free body diagram and try different mass of the block by adding incremental mass of say 1 kilogram, and redo the experiment by just applying a force until the block starts moving. And once it starts moving, we apply the force, a constant force, so that it moves with a constant uniform velocity. And then we will take data in this table with different masses. We find out what is the friction force, what is the normal force, and we try to plot this in this format to find out how this friction basically behaves as we apply more and more force to pull the block. And from that table, you are able to find the coefficient of friction. So that is the second part of the experiment. The third part of the experiment is basically using an inclined surface, excuse me, and raising the angle until the block starts moving. Okay, so we are just going to increase the angle and read the angle at the point that the block starts moving. Okay, so in other words, at that point you have the kinetic friction between the block and the surface. And by changing the mass of this, we can also repeat the experiment and find out where would be the theta or angle that the block starts moving. And that information can be used in this table here, and with different angles you can actually find out what would be the coefficient of static friction, and from there, trying this for maybe 5 or 6 trial, you can find the average of the coefficient of static friction, and then find out what is the standard deviation of this data. So that would be the third part of the experiment. Of course, there are a lot of questions in your handout that you would answer based on all the information that we provide in this experiment. And you will have also access to Capstone. We will give you the license. You can download it in your computer and actually capture the same data that we have captured here for you, and process that and answer all the questions in the lab handout. Okay, so this is what we're going to do in this lab. Okay, so we are going to increase the angle of this surface, inclined surface, and watch when the block and the weight on top of it will start sliding. Right now I have a block that weighs 241 gram, and I have 1 kilogram weight on top of it. So you need to add those and have all in a SI unit. And let's watch at what angle this is going to slide. So I'm going up to 5, 6, 7, 8, 9 degree, 10, 11, 12, 13, 14, 15, 15 and a half, 16, 16 and a half. Okay. All right, we are increasing right now at 10, 11, 12, 13, 14, 15, 16, started moving at 16. All right, we're going up 11, 12, 13, 14, 15, 16, 17, all right, 5, 10, 11, 12, 13, 14, 15, 16, 16 and a half, 17. Okay, here's the data we obtained for 5 trial. It asked for 9 times, but 5 times is enough because the data is pretty much repeating. So now you take that data, find the average value, find the standard deviation, and from there, and the relationship that you already have from your Prelab, find out what would be the coefficient of static friction. Okay, so this is the second part of the experiment. We have a block and we have a 1 kilogram mass on top of it, and we have a force sensor that has been actually zero out, calibrated, and we're going to start applying force by pulling this slowly, increase the force and capture that force versus time in capstone. So this is the first one. So we're going to add another 1 kilogram on top of that and repeat the experiment. Ready?